Earth. The cradle of humanity throughout our existence. But it won't be forever.
All it would take would be one giant meteorite to wipe us off the face of the Earth.
It's not just meteors. Our planet will change.
Our planet could freeze over, or it could heat up.
And our sun will eventually die.
We are actually near the end of habitability of Earth.
To survive in this universe, we need an insurance policy. To colonize other worlds.
Having multiple planets which are colonized is really in our interest for our own survival.
So, can we find a new home in the galaxy? Can we find Earth 2.0? For centuries, we only knew of the handful of planets in our own solar system. Now, astronomers are finding thousands of new worlds around alien stars, exoplanets.
We are discovering exoplanets by the bucketful. There are as many planets out there as there are stars, and there are hundreds of billions of stars in the galaxy.
But out of billions of exoplanets, are there any that could offer new opportunities for humanity to thrive and provide sanctuary in a dangerous universe? Is there an Earth 2.0?
Is Earth 2.0 out there? That will be truly amazing.
August 2016. Astronomers announced that Earth 2.0 could be closer than anyone ever expected. A planet orbiting the Sun's nearest stellar neighbor, the red dwarf, Proxima Centauri.
So it turns out that our nearest star neighbor has an exoplanet. It's only about 4 light years away. So that means that it's actually potentially possible for us to get there and to explore it.
Scientists named the planet after the star, Proxima Centauri b, or Proxima b for short. A world that appears to be a lot like Earth.
From the way it's tugging on the star Proxima Centauri, we know that it has 1.3 times the Earth's mass, but it's roughly the same size as the Earth.
Of the exoplanets we know about, most are uninhabitable gas giants, like Jupiter. Proxima b is a rare find, an Earth-sized planet. But an Earth-sized planet might not be Earth-like. A true second Earth must also be the right distance from its star.
The habitable zone, or some people call it the Goldilocks region, is a distance away from the star where you're not so close where you're going to burn up and evaporate all of your liquids, and you're not so far away where you're frigid and cold. So it's that special region where it's just right.
Does Proxima b lie in this region? Could it have liquid water?
Proxima Centauri b orbits its star once every 11.2 days. So compare that to the Earth, which goes around the Sun once every 365 days. That's because the planet is much, much closer to the star than the Earth is to the Sun.
Earth orbits 93 million miles from the Sun. Proxima b orbits 20 times closer, under 5 million miles from its star.
You might think that Proxima b should be, really a fried world, a burnt-out husk, if you will.
But Proxima b's sun is very different than ours. At just over 5,000 degrees Fahrenheit, it's half as hot and roughly 8 times smaller. An M-class red dwarf star.
An M dwarf, the Proxima b is around, is much less bright, much less hot. So you can orbit much closer to that star and be at the same temperature that we are here on Earth.
Proxima b's tight orbit around the red dwarf could make the planet habitable. But it would be very different from Earth. The star dominates the sky, lighting any oceans and mountains with an alien red glow.
So Proxima b may be the Earth 2.0 that we've been looking for.
But in 2017, the dim red dwarf star erupts in a way that's unlike anything we've seen before. Blasting the planet with radiation. A mega flare.
They're like solar flares, but they can be much more powerful. In fact, they can outshine the star itself.
Our sun releases powerful solar flares when its magnetic field becomes tangled. But the mega flare is 10 times stronger than our sun's strongest flares.
On an M-dwarf star, that magnetic field can get a lot more tangled than on our own sun. That means that when a flare happens, it can release a lot more energy.
Scientists believe that mega flares like this are planet killers. Radiation tears the atmosphere from the planet. And these mega flares hit Proxima b roughly once every year.
Red dwarf stars are incredibly temperamental. They are not good parents to their planets. So if Proxima b did have an atmosphere at one point, it would have been stripped away by one of these violent outbursts,
leaving Proxima b dangerously exposed to space.
An atmosphere dampens the temperature gradients between light and shadow. So in sunlight, it is just burning hot. But right next door in a shadow, it is freezing cold.
Without an atmosphere, Proxima b would be a barren wasteland, blasted by intense radiation from its star, completely uninhabitable.
Proxima b, our perhaps best shot at finding Earth 2.0 so far, is actually a dried out husk of a world that has lost its atmosphere, maybe lost any water that it also harbored, simply by being that close to its parent star.
Proxima b may be the nearest exoplanet, but it's not the only option. The future of humanity may lie in an incredible star system just 40 light years away.
We've just found a really exciting system where there's not just one chance to have a new Earth, but 7.
In an unforgiving galaxy, finding Earth 2.0 could be the difference between extinction and survival.
It's a pretty wild place out there. Our planet's not going to be here forever, and it would be wonderful if we could find a place like it that we could live.
The future of humanity lies on an alien exoplanet. The question is, where? 2016. Astronomers scanned the skies with the new Transiting Planets and Planetesimals Small Telescope, or TRAPPIST. They look for the flickering of a star, caused by the silhouette of a planet.
The planet can pass in front of the disk of its star once per orbit, causing a little mini eclipse, a little dimming temporarily in the light of the star.
Scientists spot the dimming of a nearby red dwarf star just 40 light years from Earth. The first alien system detected by the telescope, the incredible TRAPPIST-1 system.
The TRAPPIST-1 discovery was a really great bang for our buck in a sense because we found 7 exoplanets all at once.
But are any of these 7 planets actually habitable?
With the worlds of the TRAPPIST system, there's probably a range of climates. The innermost ones are probably very hot. You might even be looking at lava worlds. Farther away, they're probably worlds of ice.
But the middle planets, D, E, and F, are all prime candidates.
It's exciting to think that 3 of the planets orbiting TRAPPIST-1 are in the habitable zone, are at the right distance from that star to have liquid water on their surface.
And one planet stands out as a new Earth, orbiting just 2.7 million miles from the star, TRAPPIST-1e.
The composition of TRAPPIST-1e suggests that it could have a pretty significant iron core, kind of like the Earth does. There's a potential there for a very powerful magnetic field.
Like Earth, TRAPPIST-1e could host a protective magnetic field, deflecting the harsh solar winds and powerful outbursts that strip away atmospheres.
So a magnetic field is a good thing. It's a kind of a protection from the evil forces of the star that you're orbiting around.
And unlike Proxima Centauri, the TRAPPIST-1 star appears unusually quiet.
TRAPPIST-1 is actually a very old, much calmer star and doesn't undergo a lot of these huge flares like Proxima Centauri does.
And so it's a somewhat perhaps better system to look for an Earth-like planet, an Earth 2.0.
The data suggests that TRAPPIST-1e could have vast oceans, a protective atmosphere, and habitable temperatures. But living here would be nothing like living on Earth.
The thing to keep in mind about the TRAPPIST system is that it's very unlike our own. The planets are much closer in. So because they're closer in, their orbits are faster and smaller.
On TRAPPIST-1e, an entire year takes just 6 Earth days.
Can you imagine you're just basically tearing your calendar days off, day after day after day, really quickly? Your birthday would be today, and then tomorrow. Happy birthday again. Wedding anniversaries. You're constantly forgetting your wedding anniversary. And it would be hard.
And on this strange and alien world, explorers would witness sights unlike anything seen before.
In a lot of ways, it really is sort of a science fiction sky, the kind of things that are envisioned in movies.
You could look up and see the other planets in your sky, much like how we can see our own moon. You could physically resolve features on the surface, such as continents, with your own eyes.
But could this planet be too good to be true?
So we could have a potentially habitable planet that's really close to its star, but other issues arise when you have a solar system that's that compressed. And one of those is the potential for tidal locking.
Orbiting just a few million miles from the star, TRAPPIST-1e is likely tidally locked, with one side facing the star forever.
So you could imagine a situation where, gosh, it's constant day, and it might just produce something that's like a scorched earth, kind of like what we see behind me. But on the other side, it is constant night. And so in that case, it might just be like a frozen wasteland.
And TRAPPIST-1e's problems get even more extreme.
If you have a permanent day side and a permanent night side, the night side of the planet is going to get so cold that everything just freezes out, including the atmosphere.
The gases of TRAPPIST-1e's atmosphere could freeze into solid ice on the frigid night side of the planet. And the gases on the day side burn away. The atmosphere thins and eventually disappears. And TRAPPIST-1e ends up completely inhospitable.
So even though we found maybe a perfect planet around a star, the type of star and where it's orbiting can have a really important effect as to whether or not that planet might be habitable.
Despite its apparent potential, our future is not in the TRAPPIST-1 system. The search for truly Earth-like planets continues.
In the TRAPPIST-1 system, we find a very Earth-like world, but the star is orbiting is not very sun-like. So what we should be looking for, perhaps, is an Earth-like planet around a sun-like star.
To find Earth 2.0, we need a Sun 2.0.